Good morning, observers. We're going to be taking a look at an experiment today called Magnetohydrodynamics. And all you need really is any kind of plastic container, a fairly strong magnet. Here I have 4 ferrite magnets put together. Need a power supply. I'm using a 12-volt power supply. You can use any DC current though. A small battery will actually work, in a glass cup or plastic cup. These electrodes are just wire, iron wire, and what you have to do, just what we're doing here, what we can do is take a compass, and the red end marks north on the compass, and this will tell us which north is on this one. The south side of this compass will point at the north side of the magnet, because opposites attract. If you turn this around, then the north side of the compass will point at the south side of the magnet. So we'll start our experiment with the north facing up, and this will provide a north pole influence in the container. We'll put some everyday tap water, just normal tap water in here. Fill it all the way up, put it about half full. And salt, we have to add some salt to it quite a bit, to be honest, probably a couple tablespoons. The more salt you add, the more conductive the water becomes, and the greater the effect, the visual effect that we're looking for. And need a little bit of black pepper to sprinkle on there, or sawdust, or anything that'll float. Some pieces will float, some will sink. You know, you can see the dynamics of fluid motion is what we're looking for. Probably have to let this settle down a little bit. Put some pepper on there so you can see how the water is moving, actually from top and bottom. I'll go ahead and zoom this down some so that you all see what we're doing here. Now in this setup we have positive electrode on the left and a negative on the right, and current will be flowing from positive to negative. However, the electrons will be flowing from negative to positive, the opposite direction, which is, essentially the particle. And we'll observe that too in the experiment. We'll set these electrodes over into the solution. And again, this is under a north pole or a north magnetic influence. And we'll turn the switch on over here, and you'll immediately notice a rotation around both of them. You have a counterclockwise around the negative electrode and a clockwise motion around the positive electrode. Now, if you can look into the right and left-hand rules of electricity online and get into that, but you'll see that we would associate the counterclockwise motion with a low pressure system, and we'll associate the clockwise rotation with a high pressure system. And a lot of people will say, well, how do you explain the Coriolis effect, on the other side of the planet, that, these things tend to turn the opposite direction. How can electricity explain that? I will zoom out a little bit so you can see that we're not changing the polarity whatsoever. I'm just going to simply sit this out of the way. In fact, I'm not even going to turn it off. We'll sit this water down and simply turn the magnet over so that there's a south influence now. Now the water's under a south influence. We haven't changed any of the charge at all. In fact, we haven't even turned it off. We'll set this back in here, and well, almost immediately we'll notice that the rotations have swapped. The right hand side now is rotating clockwise, and the left positive side is rotating counterclockwise. So this is an experiment that shows that electric currents can and do influence the fluid motion on our planet, and many electric universe theorists will agree. And this is how we explain the Coriolis effect. Hope that helped. Peace and love.